our notes for section 12.5. In this section, we are going to graph quadratic functions in intercept form. So this is going to be almost exactly like 12.4, except now we are going to factor first. So we're going to go all the way back to what we learned in topic 7 or 8, I think topic 8, and just factor. So this was all in 12.4. And we're going to use these factoring steps. So a lot of you will be able to look at these and know right away, what are the factors of -8 that make +2? If you forgot, we could always make a factor list. So we could do -1 and 8, 1 and -8, -2 and 4, 2 and -4. So I'm going to use -2 and 4. So I have a positive b value, so I need 4 to be positive. And my c value is -8, x minus 2. Okay. It's a positive function. And I know that I'm going to open up. Now I'm going to have intercepts. I'm going to do exactly what I did in 12.4. I'm going to take those binomials and set them equal to 0. X plus 4 and x minus 2. So x plus 4 is 0. X is -4. X minus 2 is 0. X equals 2. Okay, so we're going to put an intercept at -4 and an intercept at +2. And then the axis of symmetry is P plus Q divided by 2. So we'll use those numbers we just got, -4 plus 2, and we'll divide that by 2. So -2 divided by 2 gives me my axis of symmetry at x is -1. Now we use our axis of symmetry to find our vertex. So we'll plug in our x value of -1. So -1 plus 4. Times -1 minus 1, or minus 2, sorry. And y equals +3 times -3, y equals -9. So that was -1, -9. My y-intercept happens when x is 0. So we'll put 0 into both binomials. Zero plus 4 times 0 minus 2. Y equals 4 times -2. So 0, -8. And then when you put 1 in, 1 plus 4 times 1 minus 2, 5 times -1, that makes -5. So we put 1 in, we got -5. And we're going to reflect that point. And now we have our parabola. Since our parabola opens up, we have a minimum value. My domain is all real numbers, and my range is the y values that are greater than or equal to -9. Okay, our next one, this is the last one, so we just have 2 today. We have -x squared plus 9. So if I was given -x squared plus 9, and I had to factor it, which is what we do, our first step is to factor out the GCF -1. So that leaves me with x squared minus 9. And now that's a dots problem. It's the difference of 2 squares. So negative 1 times x plus 3 and x minus 3. Negative 1, x plus 3, x minus 3. So my a value is negative, meaning our graph opens down. And our intercepts, we have x plus 3 is 0, x minus 3 is 0, so that's going to give me a negative 3 and a positive 3. And when we find the average of those, we'll have negative 3 plus 3 and divide that by 2. 0 divided by 2 is 0. So my axis of symmetry is just sitting on that y-axis. Now I'm going to put my vertex on there, so I'm going to plug 0 in. Negative 1 times 0 plus 3 times 0 minus 3. So negative 1 times 3 times negative 3. Y equals negative 9. So 0 and negative 9. Oh no, not negative 9, positive 9. Because negative 1 times 3 is negative 3 times another negative 3 is positive 9. So 0, positive 9, and that's what we need because our parabola opens down. Now my y-intercept, we just found it. It's 0, 9. So now I'm going to find 2 points. I'm going to find what happens when x is 1. So negative 1 squared plus 9. And 1 squared is 1, so negative 1 plus 9. Y equals 8. So we put in a 1, we got an 8. Now I can reflect that point on the other side, and I'll do the same for 2. So opposite of 2 squared plus 9. 2 squared is 4. Opposite of that is negative 4 plus 9. So y is 5. So my input was 2 and my output was 5. And I can reflect that point 2 to the left of the axis of symmetry. And now I have all of those consecutive points that start at negative 3. I've got a value at negative 2, a value at negative 1, a value on the y-axis, a value at 1, a value at 2, and a value at 3. Since my parabola opens downward, that gives me a maximum point. I have a domain always as all real numbers and a y values that are less than or equal to 9. Okay, so don't forget your rules for factoring. You could always FOIL back your answer to make sure it matches your original equation, and then you're going to do everything you did in 12.4. So this is a good review of 12.4 before we move any further.